just jump into the demo now. And so up on the screen, we've got your typical GIS environment, and you can see some cadastre there. So what we're looking at is real data from City of Greater Geelong, and we've got some drainage data in there. So that's what we'll focus on in this particular instance. The toolbar up the top is a special earthmine toolbar. So I'm going to click on the leftmost button in that toolbar, which opens up the earthmine panel. And you can see straight away it's identified that in that particular area we've got that particular imagery, and you'll notice in the imagery itself we've actually got the GIS data directly overlaid on that. And as I zoom around and pan around, you can see more of the data in that particular window. So what I'll do next is I'll just jump to an area where we could use it to actually capture data into our GIS by using the imagery. So here I've got an area, I've got a couple of pit covers on some stormwater here, and you notice that there's no entity in the GIS environment. And so what I want to go and do is go and add that particular layer as my active layer. And I'm just going to select the drainage pits layer, make that active, and then I can just go and place two pit covers in that space, and you'll see that they're actually appearing in the GIS window. And if I move around and pan to the next frame, you'll see those objects sitting there still in the same reference. So very powerful for doing that. We also, in this particular example, we use the imagery to automatically capture signs. So it's got that feature recognition capabilities as well through that accuracy. So the stop sign that you're seeing there, I can go and open up the attribute panel or a table of data against that, and you'll see all those attributes coming directly out of the GIS database. And it's worth pointing out that the technology we used here was from NICTA, and they were able to classify off the imagery various types of signs, and there are many, many sign types that they can use. And plus we could then extend that same technology so you get that automated capture. Just jumping into trees now. So let's have a look at how we can use this to create a tree database, if you like, within our GIS based upon the imagery. So here we've got a section where we've got some trees, and I'm now going to start making my tree layer active, and I'll start positioning some nodes where those trees are. So I'll click on this one here, and then I'll move to the next frame. I'm hoping your video is keeping up with mine. And we're going to capture a couple of extra ones as we go here. Apologies for the rush. And we can see those ones that we've captured, and so they're still there even though I've moved along the frame. Move to the next frame. I've got a few more trees to go, which I certainly won't be doing in the time that we've got here. And now that I've actually captured the location of those trees, I can actually start to edit the attribute data. So I can pull up an attribute table, and I can start to edit some of those particular attributes. So I'll just quickly cast them all as having medium type. Just pulling that down. Now we'll go to species. Yep, make them all eucalyptus. And finally, I'll just do the condition as we go. So they all look to be in pretty good condition, I'm sure you'll all agree. Good trees. And lastly, I just need to have a bit of a pan around in the imagery here to see whether they're going to be impacting power lines. And as you know, having to trim trees regularly that impact power lines can be a real overhead in any business managing those particular assets. So I'm going to set these all at no. We can also use this same frame to start capturing non-tree data. So I'm going to make the parking signs the active layer, and I'm going to capture a parking sign there as well. And I'll just open up the attribute table and record some attributes against that as well, and define that as no standing anytime. And of course, with the imagery as clear as it is, you can actually do that classification yourself visually. But as we mentioned, there are automated ways for those signs to be captured and classified. So now I want to just jump into another part of Geelong and start to show you that the imagery itself is not just about having very high resolution crisp imagery, because what's underpinning all of this is a high density point cloud which is being generated from the imagery itself. So no additional sort of lasers, etc. So I'm going to do some measurements here, and I want to measure in 3D this particular crossing here. And I want to measure the slope, and so I take the measure tool and I can measure that, and I can see that there's a 13-degree slope for there, and that may impact some accessibility issues, and I can measure the slope on that particular part. The other features, so let's have a look around the area. I'm going to measure the height of this particular traffic light. Now, in order to do that, I need to go and select vertical length of an object, and I'll just click on the top of that traffic light, and I'll click just on anywhere on the natural surface, and it will drop down to the surface that's been captured in the point cloud. So we're quickly just jumping through there. So 4.4 meters high for the traffic light. Of course, this all really needs to be seen in a point cloud mode, so you can be solely convinced that there actually is a point cloud underneath there. So I'm just going to draw a box here to display the point cloud. I'm going to colour it based upon first range and now elevation. Apologies if I'm going a bit too fast here. So we can see here that there are a number of pixels in the point cloud, and I can change the size of those so that I can actually see the underlying imagery. And now that I've got it set so I can see that, I might go and measure the height of that curve, and I'm going to take the vertical length again, and I can snap to a pixel in there, and I'll do the vertical height of 12 centimeters there, and I'll go a bit further along, and I'll measure the height a bit further along, and we can see that that's 5 centimeters as well. I'll just pull back from there so you get a better understanding of what we've been able to achieve. So really accurate for measuring. You can see the height of the traffic light as well being still resident there. So let's jump to the last part that I wanted to show, and this is around how can you use this technology to validate the data that's already in your GIS, or validate some data that's been captured out in the field. So here we are in another part of Geelong. This is in Lara, and we've got an overlay of the stormwater data, and so those purple objects that I'm highlighting there, they're the accurate data that's coming out of the GIS. But what would happen if we actually sent somebody out in the field with a handheld GPS to go and capture a feature, and so we didn't have those pit covers captured? And let's, for argument's sake, say that those blue markers represented where that GPS data was coming in. So now I can take that out of the GIS, and I can drag that across using the imagery and put it in its correct location. I'll do the one across the street as well. And so you can see a very powerful tool for being able to go and edit your data and to provide a level of validation against this. You'll notice how well the other data is actually aligning as well. There was no adjustment required to make that fit the way that it did. So certainly a very accurate solution. I'll just do this last one as well for you. Okay, so that sort of concludes all I wanted to show in the demonstration. So just got a couple of key points that I wanted to really highlight here. Was that asset capture and the validation was really just the beginning in using this. Imagine putting it into your customer service call center and being able to relate to your customers about what they're seeing, the height of the tree and the fence that's across the road, and et cetera, using this high-resolution imagery. We're also finding that councils are building virtual cities and 3D models, and this imagery can be used to render the facades on those particular 3D models, and nice high-resolution imagery. And we could even use it for even greater feature recognition. So it's been used for automatic signpost capture, but there are many other features that councils are responsible for maintaining that could be captured through this particular process as well. And of course, the possibilities are endless there. So what are the real benefits of tackling those challenges this way? And we've touched on a little bit about the image quality, and you've seen the pixels that have been created from that imagery. So it's really got a real crisp approach to it. It's really the fastest way to gather that data and to process it. So the cloud provides the ability not just to process, but to deliver very quickly. Usable by anyone. There's actually another viewer that can be provided that you can just install very quickly and no training required. Very, very powerful. As you saw, the integration into tools like the Esri software, it's seamless, and the other suppliers have been able to achieve that same level of seamless integration. We can scale up the data collection, the processing, and the hosting quite easily through this. The accuracy is there to support the business activities, particularly of local government, without having to send surveyors out into the field. If you do want to go and build a higher level of functionality around that image or integrate it into something else, there's plenty of tools. There's an API and a software developers kit. And lastly, the online distribution of data does provide for that rapid integration into your business. So, what are the business outcomes in taking on this particular approach? You've got an organisational-wide access to this 3D data. You've been able to take it in through a cloud-based service and push it out to a wide variety of both GIS and non-GIS users. Allows your customers to be able to focus on their core business activities. The way you actually establish this particular capture is you just order it, and then within a couple of weeks, or depending upon the size of your capture area, it can be available online and available to you all. As we all know, we're all very mindful of occupational health and safety issues and sending people out in the field to go and validate things. The use of this image can actually minimise the need to send people out into the field. Bad weather, inaccessible roads, those kinds of things, and also seasonal variations as well. If you wanted to measure the spread of a tree, you can do this all year round using this particular imagery, as long as you've driven the imagery at a time when the leaves are on the trees. And of course, here's the cloud story about having the data hosted up in the cloud. Means that you actually don't have to manage anything, no infrastructure internally, backup requirements, software upgrades, those kinds of things are all managed through a cloud service as well. And one final key business outcome is that a lot of people look at this imagery differently, and so therefore, what you want to capture out of the imagery could be different to another part within your own organisation, and so that imagery can be reused multiple times across multiple departments in that one capture. So here's my last slide. If I could just leave a couple of key takeaways from this, is that this solution is an end-to-end solution. So you request it, and then within time it's delivered and it's available online for you, and it does readily integrate into your GIS without putting additional overhead on your GIS resources as well. It's a proven solution, and it's fast, reliable, and effective. And with the Australian-based content and Australian hosting, it does certainly provide that local point of presence for the Australian customers. And of course, lastly, Geomatic Technologies are doing this now. We've been doing it for a while now. We have the ability to extend the offering as well. We're already talking to organisations who are now seeking higher densities of point cloud solutions. So putting additional sensors on the vehicle just to extend that is there as well. Plus any other integration around how do you get this into other parts of the business can be provided by GT as well. So look, at that I'll leave it and I'll open it up for questions, and I'll pass it back to you, Clint.
Thanks, Ross, and thanks for keeping to time, which means we do have time to go through a few of your questions today. As I pointed out at the beginning of the discussion, please use the GoToWebinar question panel so that you can pose your questions there. please put those in right now, I guess, as we are answering the first few questions that have come through. So, Ross, the first question I've got is with regard to accuracy. How accurate is the solution?
Look, we've found that the accuracy satisfies the needs of most sort of asset management organisations. Here you've seen in that demonstration how you can actually go and measure off that point cloud. The absolute accuracy is obviously dependent upon the sensors, but you've seen when you're within range of the features that you're trying to measure, it's certainly a very accurate solution.
Right, and what happens to my own data? Does it also go into the cloud?
Actually, there's no need for customer data to go in the cloud at all. It's basically just pulling the earthmine imagery down as reference from the cloud itself. So whatever data you're creating or operating on is in your own environment. So you're certainly not pushing that out for others to use.
Okay. Another question here is, can I share the cloud imagery with other entities in my region?
We certainly encourage adjacent organisations to team up and collaborate, or even not just organisations in a local government sense, but maybe other utilities to share that, because what this process is doing is actually building a very large library of data that we would encourage others who want to access that library of data to use as well. So certainly others can access it.
Excellent. The next question is, how long does it take to capture the imagery?
We found that this really is a rapid process. We can do on a sealed road surface probably 100 kilometres of capture a day, and that's going at speed, and so that's quite a fast output, I would have thought.
Okay. And can imagery be delivered directly to council?
Oh, that's a good question, Clint, because the way that this solution has been architected is really with the demands of the customer in mind, and most of the customers were saying, look, we don't actually have capacity to go and stand up a system ourselves and manage all of this data, because we are talking about terabytes of data. And so the solution is really designed to be a cloud-based solution and a hosted solution, so that it does build a library that can be shared by others, and it does have a great performance both across the organisation and other subscribers to the library as well. And I think bringing the data in-house really sort of defeats the purpose of what this solution is designed to do.
Great. Now, probably the most predictable question here, which is, looks like a great solution, but how much does it cost?
Well, the pricing model around this is really based upon the number of kilometres that you need to cover. And so it's a price per kilometre pricing policy. So if you're a small organisation and you've only got 100 or 200 or even even less, then you're really just paying for the kilometres that you access as well. And so it's a flat fee across that. So I think it's worth having that discussion if anyone wants to talk to us about that.
Great. Questions coming in really thick and fast now. Just mindful of time, so suggest that we'll just answer a couple more and then maybe take the other questions offline, but they will all be answered individually. So next couple of questions are, can I use it if I don't have GIS software? Sure.
There is a viewer, just a standard viewer, which you can just install on your desktop as well, and it's got the functionality to go and capture features and then save those locally as well. So yep, you don't need to have any GIS software resident at all in order to use the image, and you just connect it to the URL of the library, and away you go.
Great. And one last question that will sneak in on a half-hour limit, which is, what cost savings can be achieved by managing street trees in this way?
Well, street trees, as you would appreciate, are a pretty labour-intensive activity. Going out and visiting those, and we were talking to one particular customer about the cost that they put on that, and the savings are around about 75%. So I think in raw numbers it was roughly something like $4 a tree to go out and visit a tree and then record that information. And to do it using this particular approach, it's around about $1 a tree. So significant savings.
Fantastic. Okay, thanks Ross for a great presentation today. Just before we conclude, please take down Ross's details, which should be on your screen right now. And what we'll also do is at the conclusion of this presentation, we'll give you a survey just to capture some information from you with respect to today's presentation. So thank you very much, Ross, for the presentation, and everyone for attending.
Thanks, Clint. Thanks, everyone.